Hello friends, welcome to this session. In this session, we are going to start a new unit. The unit name is Bending and Shear Stresses. In the earlier unit, we have studied bending moment and shear forces, which are set up at various cross sections of the beam. And whenever there is some external loadings are applied, at that time bending moment and shear forces are set up at various cross sections of the beam. And also we have discussed the various methods to estimate the bending moment and shear force for the various sections of the beam, and also for the different types of the beams, that like a cantilever beam, overhanging beam, continuous beam, simply supported beam, so that we have estimated the bending moment and shear forces whenever there is external forces or external loadings are act. After that, bending moment at a section tends to bend or deflect the beam, and the internal stresses resist its bending. So that we are going to study in this particular unit, that whenever there is a loadings are applied, at that time the bending moment acts at its end at various sections, and it tends to deflect the beam or it tends to bend the beam. And whenever it is acting at a section, at that time some of the internal stresses are developed into the various section, and that internal stresses are resist that bending moment, and the shear forces develop at various sections. So first of all, as we know that the beam is a structural member which has negligible cross section compared to its length. So we have already defined the beam. The one of the length of the beam, or one longitudinal length of the beam, is larger as compared to the transverse direction or transverse length of the beam. So that the beam carries the load perpendicular to the axis. So due to the loading of the beam deforms. So in the longitudinal axis of the beam, there is a loadings are applied, and because of this loading, the beam deforms or deflect. That it is called as a deflection in the direction of the loading. So, and because of this loading, this deflection is due to bending moment and the shear force generated at various sections as a resistance to the bending. So you can see in this particular figure that there is a beam is there, which is supported at its end, and there is a loadings are applied onto this beam. So this is a uniform type of the load is acting, and after application of the load, there is a here the beam is deflects or beam is bent uh, in this section, and because of this loading, that this beam is deflect or this beam is bends, and there are internal stresses are developed to counteract this particular bending or this deflection. So this resistance in the form of either tensile and compressive stresses in the cross section, and that resistance to counteract this bending moment and this shear force, uh, it is called as bending stresses, or it is also called as the longitudinal stresses, because that stresses are applied in the longitudinal directions. So this, in this figure you can see that this is a cross section, original cross section of this beam, and this is the longitudinal section of the beam. And you can see after application of the external load, suppose there is a uniformly distributed load is acting, and you can see what will happen after application of the load in the top fiber. So this is the top fiber, top portion of this beam, and this is the bottom portion of the beam. So it is under it is subjected to compression whenever there is a load is applied. Once the beam is bent, and the bottom fiber got the subjected to tension. So this is the particular theory of this bending whenever there is external loadings are applied. So in this particular unit we are going to study that whenever the external loadings are applied onto the beam, so what type of the changes are happened into the cross section of the beam, and how much resistance offered by the beam to counteract this loading in the form of shear forces and the bending moment. So basically we have, in the previous unit we have studied that bending moment and shear forces, and we already studied the methods to estimate the bending moment and shear forces. So as we know that bending moment is the internal resistance moment to counteract the external moment due to the load. Means it is the internal resistance moment to counteract the external moment. So external moments are because of the external loadings. So there are various types of the external loadings are applied onto the longitudinal axis of the beam, and because of that, that moments are created, that moments are external moment. And to counteract, to resist that moment, so some of the internal resistance moments are also acting. That internal resistance of the moment are called as bending moment. So mathematically we can also determine the bending moment. So it is, if you define the bending moment, it is equal to algebraic sum of moments of the loads acting on one side of the section. So it is algebraic sum, either positive or negative. So whatever the moments are there, if it is there clockwise, as science convention you have assumed that clockwise movement, suppose if you consider positive, anti-clockwise negative, at that time you can take the appropriate direction and appropriate sign conventions. So that's why here word is used, that algebraic sum of moments of the loads acting on one side of the section. So you, if you want to finding out this movement at any particular section, at that time you can take either left side of the section or right side of the section. So that algebraic sum, if you find for that particular portion, so you will get the bending moment. And also some in other way that bending moment also defines is the unbalanced moment on the beam at that section. So it is also in the form of that unbalanced force, you can call it as unbalanced moment on the beam. Okay, so after that, shear force. So as we know that shear force is the internal resistance developed to counteract the shearing action. Why the shearing action taken place? Because of the external loading. So because beam is loaded with the external forces, and because of the external forces, that some of the sections are taken place in shearing action, and because of this shearing, so some resistance are also offered or counteract by the beam, and that resistance developed to counteract that resistance, it is called as the shear force. So shearing action due to external loadings, and for the resistance it is offered, that resistance is called as shear force. And also this is a one way, and mathematically also you can determine, because the definition is there, it is equal to algebraic sum of vertical loads. So because you know that some reactions are there, some vertical loads are in the opposite in the downward direction, that we have studied in the unit number 2, that bending moment and shear forces. So it is algebraic sum. Positive, if you are considering the sign, upward forces positive, downward forces negative, at that time, so you can take the algebraic sum. So that algebraic sum of vertical loads on one side of the section, and this act tangential to the cross section. If you take any of the section, at that time there are tangential forces are there, means one force is in the upward direction, another force is in downward direction, to balance that section. So that's why it is algebraic sum of vertical loads, and it is tangential to the section or cross section. Getting? So these terms you already studied, but for your information again I have taken this. Bending moment means what, and shear forces means what. After that, some few other important terms are there that we need to understand. So first is the moment of the force. Already we know that how to determine the moment. If the force acting on a finite size of body, they may produce a turning effect. So to finding out this moment, we are taking very finite size of the body or very small element, and which produce the turning effect. And this is measured by the moment of the force. So it is determined, or it is measured in the form of moment of the force. So mathematically the moment of force, as we know that the force is F, suppose applied at a point P, and if you want to finding out the moment at other section or other point like A, at that time we know the force and we know the D. The small d is the perpendicular distance from the two stations from P to A. So at that time moment we already knows that force into perpendicular distances. So that you moment of the force you can determine, so that you remember this. If it is a force is there, and if you want to finding out the moment at any particular station, at that time you should know the perpendicular distance and the force applied at that point. Understand? After that, radius of gyration. So many of the times for various axes, we need to determine the radius of gyration, and that radius of gyration is symbolically represented by small r. And as we already knows that moment of inertia for a various type of the section, like a square section, circular section, hollow square section, hollow circular section. So we can determine the moment of inertia because in the any particular section there are three different axes are there, that we called it as a x axis, y axis, z axis. So about any particular axis we can determine the moment of inertia. So here the radius of gyration, the distance from an axis at which the mass or entire area of the body may be assumed to be concentrated, and at which the moment of inertia will be equal to the moment of inertia of the actual mass of about that axis. So this is the radius of gyration, and the mathematically radius of gyration can be determined. You can see it is represented by r. Suppose if you want to finding out radius of gyration about x axis, so is equal to under root of I xx. Is I is the moment of inertia about x axis, and divided by the area of that body. So here, and if you want to finding out the radius of gyration for y axis, at that time only moment of inertia you have to take for that axis, that is y divided by area. And the unit of radius of gyration is mm or centimeter, etc. So r, it is represented in mm or centimeter. So we are just seeing that these terms, because that terms are important, how to determine that terms or how to measure. Second is the second moment of area or moment of inertia. So first, mathematically we have first moment of inertia, moment of force, first moment of force, that is m, can be determined as we know that force into perpendicular distance. That formula is already know that this capital M is the moment about any point can be determined by force, and the small d is the perpendicular distance. Second moment of force, if you want to finding out, again you have to multiply by distance. So F into d into again d. This is the first moment of force, Fd, and this is the second moment of force, Fd into again multiply by perpendicular distance. So that is, it is thus in the case of first moment and second moment of force. If you want to determine for the moment of area, at that time same principle is applied. So in terms of the area, we have the, suppose first moment of area means area into, that is the distance or that center of gravity, x is the distance of the center of gravity. So first moment of area, a into x, and second moment of area or moment of inertia, again you have to multiply by that x, the distance from the center of gravity. So ax into x. So I guess same like this, if you we have determined like a second moment of force, and here it is a second moment of area, only you have to take instead of force that area and the distance from the CG. So here ax square, that second moment of area, x is the center of gravity, and unit of this second moment of area is mm raised to 4, meter raised to 4, centimeter raised to 4, etc. And statement you can write the second moment of area is defined as the summation of area times the distance square from a fixed axis. So means this is a centroidal distance, that is a y square, and dA is the area of that particular small element or that body. That's why it is a summation. That's why it is taken that limits or this y square into dA. Next important term is perpendicular axis theorem. The sum of moment of inertia about any two axes is the plane in the plane is equal to the moment of inertia about an axis perpendicular to the plane. The three axes being conquered, that is three axes exist together mathematically. So here you can see into this figure, this is a plane of the body, and in the plane of the body there are two axes which are conquered and which are perpendicular to each other, and which are passing through the centroid of this body. So this is the x axis and this is the y axis. And here this perpendicular axis theorem says that uh, the sum of moment of inertia about any two axes, like x axis and y axis, if you find the moment of inertia about both of these axes, then it is equal to the moment of inertia about an axis which is perpendicular to the plane. So here only two axes you can see, but there is a third axis is also there, which is in the zz direction, which is perpendicular to this plane. So this is a plane is there, that's why you have seen these two axes, and third axis which is zz axis, which is perpendicular to this plane, and that moment of inertia of that perpendicular axis, or you can say in the longitudinal axis, is equal to sum of moment of inertia about this x and y axis. So mathematically this it is written that is equal to summation of these both of these axes, that ixx, that is the moment of inertia about x axis, and moment of inertia about y axis, and that summation is equal to moment of inertia about zz axis, that it is called as the polar moment of inertia. So you can see, and that is symbolically represented by j. So this j is equal to moment of inertia about x axis and about y axis to the plane. So you have to understand here, because you have to realize that this is the plane of the body, and in the plane of the body there are two axes, and the third axis which is perpendicular to this plane, that is called as the polar moment of inertia, and that can be determined by moment of inertia of this x and this y axis. Getting? And next, parallel axis theorem. So parallel axis theorem states that the moment of inertia about any axis is equal to the moment of inertia about parallel axis through the centroid plus area times the square of distance between the axes. So this is a statement of this parallel axis theorem, but mathematically it is written like this: izz is equal to ixx plus ah square. So in this figure you can easily understand that if you want to finding out that moment of inertia about this any axis which is beyond this particular plane, you can see this zz axis, and we have to finding out the moment of inertia about zz axis at that of this plane. At that time you can see this xx line or x axis is passing through the g. G is the centroid of this body or of this plane, and small h is the distance between these two axes. Capital A is the area of this whole plane or area of this particular figure or body, and mathematically it is shown that izz is equal to ixx plus ah square. So in the figure you can easily see that any particular axis is there which is beyond, which is far from this body. At that time that moment of inertia can be determined by taking that moment of inertia about centroidal axis plus area and the perpendicular distance between these two axes is square. So that statement and um, this formula mathematical expression to determine the moment of inertia of any axis. This capital A is the area of that figure. Okay, understand here parallel axis theorem. So in the figure and in by this expression you just have to remember that perpendicular axis theorem means what, which is normally that polar moment of inertia, and this parallel axis means that moment of inertia is determined for any axis is equal to moment of inertia for axis of which is passing through centroid plus area into h square. So small h is the horizon that distance between perpendicular distance between the two axes. So I think you understood here these important terms. So in coming lectures, so we have to use these terms in the various types of the problems to solve. And also we need to remember this expression, because in many of the occasions we have to see that how to determine these terms, like a moment of inertia, radius of gyration, uh, moment of area, second moment of area, like this. I hope you understand here. This is the only introductory part of this bending stresses, because this is the first lecture. We have started the bending moment, and we have understood already the bending moment and the shear forces in the earlier unit. And this unit is the bending stresses and the shear stresses. Just we have started only the introduction of the bending stresses. So that's it here. Thank you very much.